Good afternoon, everybody. Thank you for joining us and getting quite clearly on time to us for the last session of the day. Well, at least the last session before the reception. So we're between you and the reception, but I'm sure we're going to have a very good conversation now with this esteemed panel on how to achieve circularity in the automotive industry. I'm presuming you know who I am, so I won't go through making any more introductions there. But we've got on the panel here then Aurel Ciobanu-Dordea, who is the Director of Directorate B on the Circular Economy at DG Environment. So thank you for joining us, Aurel.
Thank you for the invitation.
Next to Aurel, we have then Stefan Christiernin, who is Head of Engineering Research at Volvo Cars. Thank you for joining, Stefan. And then a well-known face in this session here, in this conference here, Thilo Bein from Fraunhofer, who is Head of Knowledge Management at Fraunhofer. And next to Thilo, we have FabriceStassin, who is Director of Government Affairs for Electromobility at Umicore, but is actually here on behalf of the Batteries Europe Partnership, BEPA, tonight. Thank you. And we have Wolfgang Nuechter, who is an Operational Sustainability Officer in the Mobility Electronics Group at Robert Bosch as well. So we have an excellent panel. Thank you, Wolfgang. So just to give you a few words of introduction here before we hand over to the panel conversation. Clearly, with a changing geopolitical landscape and increasing demands on natural resources and critical raw materials, circularity concepts are gaining more and more attention, and we have a session on this aspect also later on in the conference as well. But given this, the question becomes, what would a circular economy mean for the automotive industry, road transport research, an industry that is producing over 85 million vehicles? And clearly, the industry is well on its way with regard to sustainability. We're covering new energy carriers, we're addressing some of the infrastructure aspects, but to be clear, as I've read in one recent report, only with circularity can we finish the job. So we're talking about how we're going to finish the job here a little bit as well. Circularity in Europe at the moment, as far as I understand from a report in 2022, is only at about 11.5% within Europe. So we've got a long way to go. So we've obviously got lots to discuss today as well. So thank you for joining me, gentlemen. I'll kick off by posing a question to Aurel, if I may. The political picture has condensed, but is also maybe a little bit complicated over the last few years. We've got various strategies being developed, for example, the Critical Raw Materials Act, and a number of legislative proposals, for example, the Eco-Design for Sustainable Products regulation. For me, as a non-expert on the panel here, it's a bit confusing. So can you guide us through these strategies, these proposals and these regulations, please? And maybe give us an insight as to what could still be to come. Aurel, the floor is yours. Thank you.
Only good things. I'm here to tell you about these good things that are to come, but I would like to start with a remark that you've made. Only with circularity we can finish the job. Apologies. If I would tell you this, I took it as a joke, I would be lying to you. We are not claiming that circularity is a silver bullet or is the cherry on the cake, but the indispensable cherry on the cake. We are saying that since 20 years, or maybe even then more than 20 years, Europe, and it used to be also North America and so on, are putting in place ambitious policies meant to reduce the impact of climate change and to decarbonize our economies and societies. After a long period of time, many of these measures have attained their results, and more or less, and we come to see that this is still not sufficient. These measures are still not sufficient. So we need more hands on deck. And one of these hands is circularity. We are not claiming that it's the silver bullet or that it gets the job completely done, but that it is an indispensable ingredient in our economies and societies towards decarbonization and reducing significantly their reliance on fossils in general. Now, you are right, the policy and regulatory landscape is somehow complex, indeed, but I would like to say that if you take a little bit of a more granular view, you can see that in support of the automotive industry drive towards decarbonization, we understand very well as well that competitiveness is also necessary. You cannot decarbonize but win the fight for customers and for markets and become uncompetitive compared to other customers. So we have tried to tailor some of the interventions that I will mention here succinctly that have been already adopted at the level of the European Union, and some which are expected to come or are pending, in a way that supports also the these industries strive for becoming more competitive. Because we believe that circularity, if properly implemented, and if implemented at scale, can also contribute to the reduction of the costs of the materials that are used by this industry in manufacturing, and can contribute to the consolidation or to the strengthening of the strategic autonomy of this industry, which is not the only one to suffer certain shocks from the geopolitical uncertainties or plain weaponization by some of the big geopolitical actors of the control they have on critical raw materials and other important materials, even if not critical. So I would like to draw your attention, but I guess that at least the co-panelists are probably even more familiar than myself with these recent interventions. I think this drive towards decarbonization, circularity, and competitiveness has inspired the batteries regulation, which is instrumental in particular for the electrification of the car park in Europe, and not only in Europe, and which is by now adopted, and we have started its implementation, and an important number of measures are to come about, for instance, recycling efficiency and recycled content, and the carbon footprint of the batteries for electric vehicles, notably. And if I were to say something in a sentence about what we aim at when we roll out, as we roll out the implementation of the batteries regulation, is that we have understood the message from the enterprises and from the markets of respecting the timeline for the different regulatory interventions, delegated acts, implementing acts, some of them of critical importance for the proper functioning of the markets. And we will strive to be there in time, in accordance with the timeline which has been laid down in the batteries regulation. Another important piece of legislation which is in the making is represented by the proposal for regulation enhancing circularity in the sector of the automotives. We call it end-of-life vehicles. It is a merger of two directives, the type approval directive and the end-of-life vehicles directive. Its objectives are several in number. We have a problem with the management of the end-of-life vehicles, but because we want to improve the material efficiency, the resource efficiency. We are also addressing a number of, we have included a number of important changes when it comes to the design of vehicles in order to allow, for instance, their dismantling at the end of life in a more purposeful, in a more meaningful, and in a more effective way, so that more aluminium, more steel, more critical raw materials, more plastic is recovered at the end. It is true that the landscape does not end here. The horizon scan does not end with this. You are certainly aware that for the narrative of the current, the political narrative of the current Commission, a communication called the Competitiveness Compass has been adopted at the end of January, which lays down the bright lines of the sustainability and economic and industrial policies that the Commission will promote during this mandate and that will put on the table of the Member States and of the European Parliament. It tries to respond to some critical situations in several industrial sectors across the European Union. The automotive industry is one of them. We try to respond also to the critical situation of the chemical industry. It's relevant, for instance, for the manufacturing of polymers that go into cars. We try to address some challenges which are high on the agenda of the steel and aluminium industry and several other energy-intensive industries. So this is why I would say the competitiveness compass is important. At the end of February, another policy paper will be adopted by the College to go into the specifics of what would be the type of measures to be expected from the Commission. This document will be called the Clean Industrial Deal. We aim, by going more granular than the Compass was at the end of January, to give a time perspective to everyone, to prepare for the measures which are in the design stage, and also to call on everyone to engage with us. And I think this engagement is particularly relevant, for instance, here tonight, when we speak about the automotive industry, because the President has decided, in agreement with a number of members of the College, to launch a strategic dialogue for the automotive industry. And this will be very important for fine-tuning and for you to influence the mind of the policymakers in the European Commission. And I would say there will be other political actors that will participate in these dialogues, so you can come and suggest what can improve the strategic autonomy of this sector, what can improve the material efficiency in this sector, what measures of circularity can be brought further on board without redoing the ELV regulation. But if we can do more, for instance, in the Circular Economy Act, which is also a commitment for the end of 2026, can we come forward with minimal criteria, a short list of criteria, easy to implement by the public authorities making public procurement across the European Union, and they need to be easy to implement for the municipalities in Cyprus or Malta, and for the municipalities from the north of Finland, and for Portugal and for Romania. Yeah, so we really need to speak plainly and to think about operational public procurement criteria that could support, that would create demand for cars, for different types of vehicles that meet a minimum set of requirements, for instance, in terms of circularity, in order to leverage the public procurement in support of creating demand, so much necessary for an industry that we understand and we sympathize undergoes a compression of the demand. So how can we revamp demand in this way? So I would stop here. I think I might have exceeded my 10 minutes, but I am keen to exchange with the colleagues here and also with the audience.
Excellent. Thank you very much, Aurel. You've given a very comprehensive picture of what's happened, the dialogue that's going on now strategically, and maybe what's coming to the future as well. So I think you've given a very good basis for the rest of the panel to come in with a variety of different perspectives on the whole situation as well. And we've got plenty of time for a good discussion. So we'll come back to you, Aurel, with some answers, and we'll go on from there. But if I may move on to the automotive industry as represented by the OEMs, now by Stefan here. Clearly, you're adapting to these new requirements that are coming along, but what exactly are you doing? And maybe from an economic perspective, because that's been brought up a little bit, what is your thinking about the implications of circular economy regulation and adaptation? Thank you, Stefan.
So, thank you so much for this introduction. First of all, I would like to quote our CTO, Anders Bell, and his view on the automotive industry can be condensed into 3 words: energy, matter, and code. So if you're on top of code, software-defined vehicles, you're on top on electrification, that's half the carbon footprint. What's left then? It's matter, it's material. So material is super important for our future. As a company, we had set the goal and target for ourselves to become fully circular by 2040. That's ahead of policy. And one of the reasons for that is that we see if circularity is done right, it can be done wrong, of course, but we aim for right. If we're doing it right, it's going to be a gold mine. It's going to be positive for future business. So I'm going to give you a couple of examples and then return back to what we could do more together, all of us. But if we take the case of aluminium, now we were the second company in the world after the first one, which I'm not going to mention, that took the strategic decision to go for so-called mega casting, which also enables us already just going from sheet steel to aluminium. We managed to lower the footprint by some 15–16%, and then to going further into circular aluminium, you can reduce it much, much more. And now here comes all the science part. It becomes more difficult the more circular aluminium you get into the melt, of course, because you get new material characteristics. You need to have very speedy ways to do characteristics on it because it's high volume, high speed. You need to estimate the quality, to introduce new design tools. So a lot of very good research subjects. And those subjects might, in the applied science phase, need or benefit greatly from booster actions from the Commission, joint research, Pillar 2 activities, of course. So that's great and necessary. But when it comes to the end game, because the business side needs to be sustainable as well, I brought you a prop here. It's an aluminum can. And it's very good business. When I grew up, I'm old enough to remember the drives, keep Sweden clean, don't throw away the can, etc. Now, with the event of a deposit system, new technology, a Swedish company that invented the circulation machine. Tomra, exactly, Tomra. This is a good business. So, no shame in it, perfect circularity, and a new good business. Now, cars are much more complicated, of course, but it stands as an example. If you go to steel, you mentioned steel. Now, at the end of life, dismantling is cumbersome, expensive, But we need to do it, and we need to do it in a smarter way. And ideally, you would like to shred the top hat, the metal part, but then you get copper into the steel and iron part. But there are actually suggestions from the steel industry that would require new technological infrastructure, new research actions, innovation actions that could solve this. And then we have a situation where we get a European source of steel, circular steel, that would stabilize, help stabilizing steel prices, because the last 5 years been up and down between $300 and $1,800 per ton. And right now it's 852, I checked before entering. So there are a lot of opportunities here working together. So, and I noticed my 5 minutes, so I'm not going to wait for a clock, but that's some of the ideas here. So done right, good business, but we need to work together on the booster part.
Thank you, Stefan. That's a good set of examples and a positive piece of news as well. What I'll do is, if you don't mind, I'll just carry on down the line to give everybody a chance to speak once. Let's go through a little bit of question and answer session, and then there's going to be plenty of time, so please then everybody gets a chance to come back in and respond to it. Does it taste good as well then? So let's move on to Thilo Bein as representing the research and technology organizations. And maybe you can help with some of this innovative steel aspects in the circular economy. But to truly implement the circular economy in the auto industry, one aspect that we need to investigate further and create possibly is this concept of the reverse manufacturing. The European Commission, as far as I understand, has expressed the interest to fund some of these aspects in the future, so it's obviously something worth talking about. But what is reverse manufacturing, and what could its implementation look like for the auto industry, perhaps in relation to, for example, batteries, which have been a topic of much discussion this last day or so? Thilo, please.
Yes, thanks a lot, Simon. I think Stefan already indicated some of my answers. So reverse manufacturing is basically a central part which need to take place at the end of vehicle life. So we have about 10 million cars yearly to be coming to an end of life in Europe. And these vehicles needs to be dismantled. We need to dismantle them in an efficient way to extract valuable components, to extract valuable raw materials. This dismantling needs to be done in combination with a smart assessment. What can be done with the components? Can they be remanufactured? Can they be reused? In case of batteries, this is then a second life. Or are they degraded in such a way that we have to recycle them and recover the high-value materials? There are problems associated with this. And as Stefan indicated, we have to pull different stakeholders. At the same time, we are facing the problem that the recycling industry is rather defragmented in Europe, and they are doing recycling not only for the automotive sector, but also for any other type of market, and then the recycled materials is of lesser quality. They're putting together household equipment with car bodies and so on. So the quality is not in the way the automotive sector needed. And Aurel, you mentioned implementation in scale. So to do this, we have to invest in infrastructure. We have to invest in R&D infrastructure. As Stefan said, we need to automate the dismantling process. In terms of a battery system, normally the cells are welded, and we have to have a precise technology which can disassemble and take out the cells, as an example. And that must be fast and efficient. At the same time, we have to check if they can be forwarded to a second life, so in station, for instance, in stationary application, or do we have to recycle the battery cells to obtain the precious materials? There are other examples. We also have to consider the logistics behind it. We have to pull the vehicles all over Europe, and then the good solution might be that we have centralized infrastructure where the vehicles are dismantled, and maybe also then the recycling is in the same area, so that we do not have to ship. Shipping of batteries can also be a problem. And for that, as I said, we do need infrastructure, and we heard yesterday the idea of flagships. So there are a need to invest in big projects where we build up infrastructure to validate and demonstrate the required technologies. This is the automation, this is the remanufacturing, this is, besides the battery, we have the plastic recycling. We have to think about how plastic can be recycled also in closed loop, that we have the proper quality. We, let's say, also have to demonstrate that this is a viable business model, that it is cost efficient, it is energy efficient. Where does the energy come from needs to be solved also within such a flagship project. And for this, we have to pull different sources of financing. And this cannot be done only by the automotive industry. We have to bring in all players. And yeah, and such a flagship can build up R&D infrastructure where we can validate and demonstrate the technologies, and then that can be scaled up. And I think this is quite important, that we show this, it is a viable business model, and that we can show it that this is also for the advantage of the European competitiveness. I'm quite convinced, as Aurel said, the implementation in scale of the circular economy is also a competitive advantage for the European automotive industry. And if you look into a longer perspective, it's also then, of course, a concept which we can transfer to other regions of the world to generate value and to strengthen our economy. It doesn't make sense that we, about 4 million cars per year disappearing somewhere in the world, and there are, let's say, misused in a way which is not very environmental friendly, phrase it like this. And we have then, of course, also implement these technologies in other regions of the world, which then again generate a value for Europe. Just in brief.
Thilo, thank you very much. An RTO comes to the stage, so we've got lots of research questions, and we definitely need some funding to help solve some of these questions. So we're going along the right direction with this, but you've brought up some other interesting points as well. So I'm not hearing complete agreement yet, so there's plenty to discuss as we go along. But let's move along to Fabrice, for yourself there. To truly embrace circularity, I think, as Thilo has suggested, we need to ensure that all materials being used to both produce the vehicles, being used during the vehicle's use and operation, that all of these are recycled. So it's maybe a logistics matter, it might be other things as well, recyclable, recoverable. Where do we stand, and what are the critical barriers? Maybe not 20, 30 years down the line, but in the next 5 to 10 years, what do we really have to do from your perspective?
Yeah, so thank you. I see 3 groups of challenges, if I may say, that you need to overcome in the future. They've been with us for many years, so basically it's not changing a lot, to be honest. Is that first we have to realize that circular economy does not start with recycling. It starts with the product design and the manufacturing processes. So if I take the example of EVs, electric vehicles, there is a lot of work going on in chemistry labs to be able to do with the same amount of metals a battery with higher performance, right? So for example, if you can push a bit the voltage, you can actually store more energy, so you need a smaller battery. For stationary applications, you may need maybe to consider sodium-ion batteries that maybe pull you a bit away from the lithium. And then there is the future technology of solid-state batteries that could also deliver a big jump into energy density, and so you could do the same with less. So that's one element that you have to take into account. Still at the level of the design, it's also the product design. If we could make sure that the products do not break down as easily, that we have repairability also in mind, durability, it helps. And then something that we also forget sometimes to mention is that in producing stuff, we create a lot of waste, especially in the beginning when we establish new production processes in Europe. For example, those that are trying to make in Europe battery cells, they have a huge scrap rate. Basically, they're burning cash like hell. So you need, of course, to be able to recover this scrap for as long as the process is not optimized. So this is really at the level of the design of the product and the design of the processes that manufactures the products. Then the second challenge, and this one is, of course, as you can see, quite a lot important, enabled by the innovation. It's a lot of product and process innovation. The second challenge is collection. But if you collect something, don't lose it. There is still a lot of stuff which is leaving Europe, to be honest. And there are lots of loopholes that are not being closed efficiently for the moment. And if you want to export stuff outside of Europe to be treated, make sure it is treated in the same conditions, because as Europeans, this is not ethical and even moral that we are asking people to treat our waste in substandard conditions that we will not accept for our friends, children's family in Europe, and also for the environment. And the last point, I think, with collection, it's also very important to see all these digital product passports that the Commission has been working quite hard about, because if you have track and trace systems, you become accountable and you can try to solve the problem as well. And then the last challenge that I see is there is good and there is bad recycling. And I've seen videos and pictures of bad recycling. It's really crazy when you see it. If we want to recycle in Europe, we have to recycle well. That means high quality recycling processes that emit very little CO2. Pollution should be minimized. The water consumption should be minimized. The amount of chemicals should be minimized. Even the land use should be minimized, having very dense processes. And then those who recycle still need to make a bit of money, because we're talking about business here. So we need to have profitable businesses that will be able to provide the benefit to keep on expanding and recycling for Europe. So these are the three big challenges that I see. Maybe a last one, which is maybe for later in the conversation, is that we need an industry to do that, right? And so we need to create the enabling framework that enables an industry to say, I'm going to spend hundreds of millions of euros into recycling. Does it make any financial sense or not? And so there is a lot of industrial framework, industrial policies that we hope to see, of course, with the new incoming commission that is supposed to, of course, and making this a strong industry for Europe.
Thank you, Fabrice. Excellent points, a pragmatic view of what we have to do inside of Europe, but also looking at some of the morality and some of the industrial aspects further on. I think you've raised quite a few points that other people will come back to on in a moment, but maybe you've been focusing perhaps a little bit considering the battery aspects, given your position inside of BEPA and so on, but if I can move on to Wolfgang briefly now, the car isn't just a battery. Even still, there are plenty of other atoms, other matters in there as well. So what about for example, the electronics, the semiconductors? They're clearly getting more and more complicated, more and more important inside of the vehicle, but what are we going to be doing about their recycling and reuse? What is coming in that direction, particularly when we move to connected and automated vehicles? There's going to be more and more of it. Have we got the capability to recycle that in a circular economy as well? Thank you.
Well, actually, if you look at the car, and let us beam back 50 years, we had a handful of electronic control units in our in a car, and now we have about 50 or even more electronic control units in a car. And if you look at the climate impact of a car, at the product carbon footprint, as you see it on several statistics, for sure, everybody talks about the battery and the steel and the aluminum because that's the heavy components inside. But then suddenly you see that on the 4th to 6th place in this strategy, evaluations, you see that the electronics comes up suddenly. And this is exactly the reason for what you have expressed there. We have electric cars, you need electronics to drive electric cars. You have all the connectivity and the entertainment and all the stuff inside the car which we want to have. And therefore the content of electronics still rises in a car. And so this problem is emerging. So, okay, we have seen we have a problem, and the question is, where is the problem at the electronic control unit inside? Where's the challenge? Yeah? And one challenge for sure is that this is not one block of metal inside the car, but electronics is very distributed. So you have these sensors and actuators everywhere in the car, and they're very tiny. And if you now zoom in the electronic control unit, you can say it's two parts. You have a connector and a housing. So at that point, would say if you scrap a car, you shredder the car, then you can retrieve the housing. Yeah? But you are still not on the electronic side. And there really we have a challenge. Because if you look at the weight distribution of electronic control unit, let's say 80% is the housing and 20% is the electronics. And if you then zoom in on the semiconductor devices, then it's really a small percentage on that point. So we have really a very low amount of material on the electronic side. But if you look at the product carbon footprint of electronic control units, you will see that the electronics is dominating the CO2 and the climate impact. Okay, and so therefore, going into recycling is not the point we can really tackle the issue, because it's not a material issue. It's a value add issue that we put a lot of energy and a lot of climate impact into the semiconductor devices, which then cannot be retrieved by recycling. So to tackle these problems, we must use other means, from my point of view. And you already mentioned it, we must go with a concept onto electronics, which is different from recycling. And for sure, energy recovery also doesn't play a role. So we must use concepts like refurbishment and repair and remanufacturing on that point. And even, as you already stated as well, let's go on not on these 4 R's, let us somehow inflationary 6 R's, 9 R's, now we add 10 R's at the moment. Yeah? And I think that these concepts are very clear at that point. You look at the design phase, you look at the use phase, and you look at the end of life phase. Yeah? And as I already stated, end of life phase is not the solution on electronics. So we must start at the design phase, looking how can we redistribute electronics in our EE architecture in the car, even going maybe into the cloud. Don't have the electronics inside our car, but go into cloud solution. Maybe also one possibility. And the second step is we have a lot of innovation on electronics. So we, for example, sensors going smaller and smaller. If you start 20, 30 years ago with the Elch test on the Mercedes-Benz, the yaw rate sensor was a handful of electronic device, just one yaw rate sensor to measure the yaw rate of the car. Nowadays, we have sensors which integrate 3 direction of motion and 3 direction of yaw rates in one sensor of 10 cubic millimeter. Very, very tiny, and so less energy consumption, less material consumption, very integrated and much innovation behind. So we can really reduce the stuff. Miniaturization also plays a role on the ECU device. So we have the right trend here with innovation in the design phase. Yeah. But the main point we have really to elaborate on is that how to retrieve the value add we had made by manufacturing of an electronic device. And there are solutions at hand that we can remanufacture, repair electronic control units during the lifetime of the product. We offer such services to our customers, and we can here really retrieve the value of electronic control units to keep the car in the service. Yeah? But this is only, let's say, a small portion of the picture, because repairing and reusing electronic controls to keep old cars in the system is nice, but the majority will still be scrapped and therefore shredded, and then it's lost. So what we need in the end is somehow a concept that we design from the start, the reusing of electronics in the design phase already, so that we know how the concept will be, how to retrieve electronics out of a car which will be scrapped, and then look for how can we reuse electronics in a later stage in the next life. But this is unsolved at the moment, and we have to look for how we can tackle this problem.
Excellent, Wolfgang. Thank you very much for that. Clearly, you're posing a good problem there. How do we recycle, reuse the added value, because we've added the value in ever smaller and smaller components nowadays, so that's a big challenge. So we've each had a chance to bring our particular perspective to the issue now. Maybe, can I come back to yourself, Aurel, in the first place? You've been listening to the industry speaking here. Do you have any points that you want to come back on? Have you heard anything else that you think, we've got to include that in some of our policy practices in the future? Any immediate points that you want to bring up?
Listening to my co-panelists, I have to say that I have recognized all the issues and the intentions that we had, for instance, in relation to the ELV regulation, to the regulation proposal for regulation to enhance circularity in the automotive sector. Even if I haven't been granular in my comments about this proposal, I would like to say that we recognize the issues and the solutions that are there. I would only add, not to increase the complexity of the policy landscape, but I would like to say that, I mean, we are reflecting currently on number of complementary measures. So, like for instance, how can we look at the carbon footprint, for instance, of certain materials like steel and aluminum in a better way in order to take into account also the contribution that the incorporation of steel or aluminum scrap can take. I heard also the comment, I think it was from Thilo, about the scale, and indeed, and one of the big challenges for circularity in general, not only in the automotive sector, I think in Europe and probably globally, is the fact that with the rather low prices on global markets, not only for oil, but also for critical raw materials, for copper. A few days ago, somebody was talking to me about the evolution of the price of cobalt, of copper, of many things. There is a big economic challenge. How do you make the price of recyclates lower than the price of virgin? There is something wrong here. So we are trying to look at this issue as well. So not only the, let's say, the fascicles of big interventions in the ELV regulation or in the batteries regulation matter, we try to look at the wider landscape and to see how we can support a reversal of the in the economics in ways which are supportable and enhance the competitiveness, first of all, of the industry, so that we don't damage the car manufacturers or the steel manufacturers or the manufacturers of spare parts, but also to make things more appealing for the consumers as well.
Excellent, thank you very much. So you've picked up a few new points here, and we've broadened the discussion globally and then also in relation to different industrial sectors. But Stefan, I see you've picked up your microphone, so you've clearly got some response to that. And then please, everybody else, let me know if you want to bring up a point in the discussion. So Thilo, again, let's not go up and down the line regularly, let's mix it up. But Stefan, first of all, please.
Thank you. So, like this, it has at the end of the day make good business sense. We all talked about that. So again, you have to turn into a case of going for casting. It illustrates the need to design differently, to manufacture differently, to make these changes to enable both circularity and better business. The case was sound in itself. So that's super important, but taking that to other areas like electronics or other more challenging areas, I think it's really, really important what you said here about the price of circular metals or materials compared to virgin. Now, of course, if you take the entire value chain into account and you take into account smarter ways to disassemble and involve the materials providers in that, you find enough added value, new value in the entire chain. But it only works if you solve the entire chain at the same time, and you will actually end up with a lower price for the chain. But that also identifies a challenge or an opportunity, rather, in connection to the new compass, being commission compass. When you talk to venture capital investors, they value, of course, profit return, but also the lowest possible risk. That's also the reason why they love to go after the digital space, because there's only one risk: development. The distribution, logistics, how you scale, all that's solved in the cloud. If you go for material, you end up with 4 or 5 different risks. New steel mills or adaptations of existing steel mills, logistics, etc. So setting up actual de-risking activities along the value chain would also leverage private investors and private capitals in circular economy. We think that's super important to do that in connection to research and innovation actions, because then you automatically would also leverage European competitiveness in line with the compass.
Excellent, thank you. Do you want to respond immediately, Aurel? Is that?
No, I was reflecting what would be the solution. I see the point. Spreading the risk, this minimizes it and makes it bearable by the different stakeholders. But how? But maybe we don't, but I would be happy to listen to solutions, and my colleagues may be even happier than me, because my learned colleagues may understand them better than myself.
Very good. We're taking opportunities here, but Thilo, I think you wanted to say something, maybe not so much on the economics, but carry on.
Yeah, I wanted to raise 2 points. One in response to you, that you mentioned that the secondary material sources must be cheaper than the virgin one, but we also facing competition between markets. So, for instance, in terms of plastics, there's a high demand also from the packaging industry, and we are in an automotive sector. We are facing very high value plastics, and there's competition among the sources. We see, as an example, the used cooking oil is much more expensive than virgin oil, right? Because the demand is so high, and this needs to be considered somehow. And secondly, when we are talking about, of course, we have to follow up a system approach. But if we now introduce, let's say, design for circular economy, this will impact the end of life maybe in 8, 10, 12 years. We also find a solution for the existing market, and we really have to invest in a smart way to handle end-of-life vehicles. And for that, we do need data, we do need some kind of digitalization. We have to find ways how information are exchanged across the value chain. We do need the automation. And I emphasize it again, and this requires investment might be even higher than we needed for the electrification, because the current industry is so fragmented. We are doing it by hand partly. The harness will be disrupted by brute force, and then you cannot reuse it anymore. It will be shredded. 70% of the shredder fraction is lost and used as landfill waste or whatsoever. And here we need solutions.
Thank you, Thilo. Yes, we shouldn't just have a dialogue between Aurel and everybody else, so let's pass the word down and then we can come back to you in a moment, Aurel. But Fabrice and then Wolfgang. Oh, no, let's switch it around. Wolfgang, you go first and then Fabrice, just so we don't look like we're following the seating order all the time. Wolfgang, please.
Well, actually, I think the problem of knowing what to retrieve out of a car, the digital product passport may play really a good lever on that point to push the knowledge about what to retrieve from a car at which point and where to look at. So I think that is a solution which may be helping this economy really to look for the right points. Yeah. Nevertheless, if we really look what we do currently at the aftermarket for the to keep the cars in the loop with repairing refurbishment, there is currently an economic limit what type of control units you really can take out, because otherwise the logistics to take it out, the labor to take it out, to send it to us, to have the remanufacturing possible and to send it back, to reinstall it in the car, there's a certain economic limit at the moment. And I see the same economic limit on a scrapyard, if really what to take out, and so there will be difficulties if we not design the car in a way that we really can easily dismantle it in that point. And even I know that if you look at industry electronic waste, gold content is so high that it's even higher than on some gold ores in the world which are taken out. Of course, but if you look at other materials, if you just go on solder materials, on tin, on other stuffs, the economic value is so low that people don't strive for it. And therefore, I think if we cannot really push a method where we can get the things out very cheap, I see that we only rely on aluminium, lithium, and steel on recycling and closing the loop, and the others we will wait a long time until this comes economically.
Thank you, Wolfgang. So the challenge is there from Thilo, but you're saying we have to look at all the details, but we've got quite a bit of evidence already that might help us to say what's possible now, what's valuable now, and what we need to work on, both economically, but then also practically. Fabienne, I see you've been making many, many notes there, possibly even more than I have, so you must have something more to say. Please, go ahead.
It was not my shopping list. But on economics and industry, I think we have to realize that we will not recycle if there is no industry in Europe. You can have the best regulations you want, all the best intentions, all the best R&D. If no one is putting the money on the table to build the capacity, then you will just have great ambitions, but nothing real. And there are three elements I think that we need to keep in mind, is that in order to make a profit, you need to recycle at a huge scale, because this is driven a lot by economies of scale. And this means hundreds of millions, if not tens of billions, all over Europe for many years to come. So if you want to catch up with other countries, and if you want to actually be better than countries, this is a sprint, and this is actually a marathon. So we really need a lot of money for doing that. The second point is that it's difficult to get a lot of money from private investors if the regulatory framework is not clear. And so the battery regulation that the European Commission has built with a lot of stakeholders is a very nice move. I think it's very strong and stable. But there's still a lot of secondary legislation that is in the making. For as long as we do not have some clarity on some pieces of the secondary legislation, there is no decision to invest. For example, on the CO2 footprint, the delay is already more than a year to have clarity on how to calculate the CO2 footprint. It's difficult to tell that to a CEO. Huh? The third point is that if you have the scale, but you have nothing to put in your big kettle, which is a recycling process, then you have a problem. And there I think that this is slowly being tackled, but moving waste across Europe is hell. It's sometimes even easier to move the waste outside of Europe, actually. So today, if I take the example of the EV and the battery recycling industry, we are bleeding black mass like crazy. And making black mass is not recycling batteries, it's just making black mass, by the way. It's not recycling batteries. And then there is a third point, is that in order to run a battery recycling or any kind of recycling processes, there's a lot of electricity which is going to be needed. And as you know, the price of electricity in Europe is 2 to 3 times more important than in countries that we are competing with. So just to say it's good to have a regulation, I think it's a good thing to have, but then you need to have the industry willing to make the investment cases, and that's key.
Thank you. You've made some very good broad points, and clearly a lot of them have been directed towards the regulatory aspects, or you've brought in the east-west aspects as well in relation to that. So, Aurel, do you want to respond immediately, and then we'll move on to Stefan, who I know you've got some points to make as well, but Aurel, if you want to come in immediately.
Yeah, maybe three short comments. Indeed, the point on the implementing act or delegated act on the carbon footprint of batteries is the example which contradicts my thesis from the beginning, saying everyone that we will try to be on time. It's a highly controversial act. It's not the only one very politically loaded, but it's basically how do you, what kind of energy mix you consider acceptable. And there are some fierce battles between Europeans and also the problem with other jurisdictions, but we will come out this year, I can tell you. It's not a big promise. It's a very vague promise. One comment about the recycling, in particular in the batteries. I mean, we are concerned about this issue, and we understand that by putting an obligation of recycled content in the batteries legislation, the problem is not solved. And how do you make it happen in Europe? Everybody agrees that the black mass is hazardous, so it must be retained in Europe or in OECD countries, but we see that the economic pull factors drag it towards South Korea, who is also in OECD. So what can we do? And I was discussing yesterday with an important economic actor from one of the large member states of the European Union exactly about this. And with my colleagues and the colleagues from the Commission Department in charge of industrial policies, with whom we co-manage the battery regulation, DG GROW, I mean, we are thinking about maybe we can come with a novel thing. Here we need to deal with a, I would say, quadrature du cercle, as they say in French, how to square the circle, indeed, so there is an equivalent in English, easy to find. So how do you encourage the manufacturing or the recycling in Europe without posing barriers to international trade? And because the Commission and the European Union keeps this mantra of being open to trade, but how do you stimulate? And we are looking into this actively in order to come very soon with a solution to this. There is also this newer message that at the beginning of this mandate, which has been inspired by our French colleagues to promote Made in Europe in public procurement, but beyond this, how do we make things being made again in Europe? So I would stop here. I had one additional comment about the role of the closed loop, for instance, in maybe reducing the competition for recyclates you point at. The competition raises the prices. This is why we have come with suggestions about closed loop, in particular for the automotives, not only to stimulate, but also to protect the source of plastics. But I agree that the abundance of supply also can play a role. But the producers of recyclates tell us, I don't scale up, because if I am not sure about the demand, look at the plastic recyclers. They have accumulated mountains of recyclates, and the demand is just not there. So we need to find the right balance between advancing the demand pari passu with the supply, approximately in parallel with the supply, because if the gap is too much, you have, sometimes you can have a crisis. So I just would like to acknowledge the importance of the issues and that we share the same views and we are looking for solutions.
Thank you, Aurel. I think it's not surprising that we've got a meeting here today and international trade and economic prices around the world has come up, but it's a very, very important point. I know, Stefan, you raised that you wanted to come back on one point, perhaps because we're getting towards the end slowly. Stefan, if you can come back, and maybe Thilo, I had a feeling you had a point as well. But Stefan, first of all, please.
So thank you. I'm not going to deep dive in international trade. I could, but still, I mean, just looking again at how to make this work, because this is not writing a 3-minute song for Eurovision. It's more like writing a Mozart opera. It's really complicated piece of music, so to speak. One thing that is super important as we see it is the technological convergence we see in the world right now. It's data, data, and data again, both on how things are used in the car, how to estimate is it worthwhile reusing it, also how the materials has been handled, also material charge, what is the exact quality of recycled material we get in. How do we take that into the process? Could we adjust real time in the process? So if we get, because the large language models in US, in California, Google and the likes are very good at that. But if we get data right in Europe, it would actually lower a lot of friction. It would enable a lot of new possibilities, both in the OEM side, the recycling side, to follow materials, to enable new designs, and with new design methods also enable a higher content of a higher variation of quality in materials. But all that is data-driven, and whoever masters that first will have a great competitive advantage. So you can't do circular material in a competitive way without doing material data in a competitive and smart way.
Thank you, Stefan. Excellent point. 10 Rs, 3 Ds. We're getting to control all of the European situation here, and I see some nodding around the rest of the panel here, but Thilo, maybe you had one point to bring up as well.
Yeah, maybe to add another aspect. So when we're talking about the 10 Rs, we have to keep in mind that there will be no 100% circularity. We will always have losses. We heard it in the past session in the battery recycling and lab scale, they have an efficiency of 90%. So 10% is lost. In the plastic recycling, we even speak of 30% losses. So in the context of circular economy, we also have to investigate an alternative solution, alternative material sources. That in context of plastic, it must be then fossil-free plastic, so bio-based plastic or somewhere else. We have to find alternatives to critical raw materials. And one urgent aspect, which also everyone is talking about, is the PFAS situation. So we do have to find ways there to handle this in context with the circular economy, in context with recycling, because those aspects may also hindering at least the closed loop aspects.
Thank you very much, Thilo. You've brought up yet more points. I think if we carry on with this discussion, we'll get more and more input. It's a very good discussion that we've been having. Does anybody want to raise one last word at all? I give an open floor to anybody. I know it's risky at this time in the session, but if anybody wants to make one last point, please. I think we're all looking forward to the reception in a few minutes now. So I hope you agree with me. This has been a very stimulating discussion. We've got plenty to look at in this triumvirate that we've got represented here in terms of policy, technology, materials, processes, and business kept coming up, whether it was trade, whether it was investment, whether it was examples going forwards as well. Hundreds of billions of euros I heard being mentioned at some point. So clearly we've got to carry on integrating and interacting as an industry and as European community as well to make sure that we maintain our resilience, our independence, our planning and our stability. And the circular economy is a way that we can achieve this, but we've got plenty of space still to go for the next 5, 10, 15 years or so. So maybe we'll all get back together again in a few years' time in this same panel format. But first of all, thank you to all of you for your contributions today. Let's put our hands together, please. And I know I'm now the one standing between you and the reception, but I just need to say a couple more points. The observant ones, no, all of you will have noticed that we've got rather a gender monotone panel here, and I know I heard some comments about this, for which I must apologise, but let's beware, it wasn't going to be planned like this. We've got an excellent panel, we've had an excellent discussion. We did have other plans, but we had to adjust to those. So I'm glad everybody's here and we've made contributions, and we will try harder next time with regard to gender balance in that sense as well. The other point I want to raise briefly, just before we go and enjoy the reception, is about the strike that is coming up tomorrow that you know as well. We are going to be doing our best to continue as planned. We look forward to seeing all of you here tomorrow, if you can be here. But do remember that if you can't be here because you've made or had to make other travel plans in the last 24 hours, don't worry, we are online. We have a live stream as well, so we expect to see and hear you at least online if you can't be with us in person. But we're going to be doing our best, and we will still be here tomorrow. But in the meantime, then, let me invite you to enjoy the Riverside reception. Just across the way again, and all our panelists here, if you haven't been here for the last 2 days, don't worry, please do come and enjoy the time with us over on the other side of the building. I'm just looking at Lucy. Have I forgotten any news that I should be saying? No, well then, thank you very much to everybody. Thank you for your attention today. Enjoy the rest of the evening, and I will see you all again tomorrow morning as well. Thank you very much. Goodbye.